Good evening, everyone. A warm welcome to all of you joining us at the Snyder Institute for Chronic Diseases Mini Medical School Lecture Series. We're thrilled to have you here tonight for a discussion that promises to be both enlightening and impactful on the topic of the health effects of wildfire smoke. I am Mary Siliveru, your host for this evening, and before we dive into this exciting talks ahead, I'd like to cover a couple of quick housekeeping details. Tonight's program will be divided into two parts. First, each of our distinguished speakers will share their insights in a 20-minute presentation. After that, we'll open the floor to your questions. We've scheduled a 10-minute coffee break between speakers, and for those of you here in person, refreshments will be available. We encourage you to relax, enjoy, and make the most of tonight's discussion. To formally begin our program, the Snyder Institute at the University of Calgary's Cummings School of Medicine, located in the heart of southern Alberta, would like to acknowledge and pay tribute to the traditional territories of the peoples of Treaty 7, which include the Blackfoot Confederacy, comprised of the Siksika, the Begani, the Guyana First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda, including the Shiniki Bearspaw, the Goodstoney First Nations. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. And now, I am pleased to introduce our first speaker of the evening, Dr. Gwen O'Sullivan. Dr. O'Sullivan has a BSc in Environmental Science from the University of Limerick and a PhD from Queen's University of Belfast. Her research area focuses on the interdisciplinary field of environmental forensics. Through the combination of analytical chemistry and environmental science, she examines the sources, fate, and behavior of environmental pollutants to better understand their impact on the environment. She joined Mount Royal University in 2011 and currently serves as the Vice Dean of Research and Scholarship within the Faculty of Science and Technology. In this role, she provides leadership and support for research, scholarship, health and safety information, and infrastructure development. Welcome, Dr. O'Sullivan.
Thank you very much for the kind introductions. It's been really nice to be here. It's nice to see you all in person, and to those of you online, I'm excited to talk to you today about one of my passions. As the introduction indicated, I work at Mount Royal University. My area of expertise is actually environmental forensics, so I feel a little bit out of my depth here with all the doctors and the specialists, so hopefully I won't keep the level too low. I got into wildfire forensics in 2016, basically on the side of arson investigations. So since then I've been doing work for the Alberta government, for the RCMP, for the police, both in Canada and in America, looking at trying to determine if fires are set by arsonists or if they're naturally set by lightning and things like that. And that really led me into understanding the chemistry of fire, because you have to look at what fire is and how it can degrade things like ignitable liquids over time. And then since then I've moved on towards looking at wildfire smoke and characterizing it. So I'm an analytical chemist, as was indicated in the introduction. And so most of my area is related to developing new techniques and technologies to help us better characterize contaminants in the environment, and in this case, wildfire smoke. So I'm sure you're all familiar with images like this one. It probably makes you feel a little bit warm and maybe a little threatened. And so I wanted to start off by kind of putting fire danger into context for Alberta. Not that I was writing my presentation earlier on today, but you can tell from the time at which I took this is the fire danger from today. What's important about these kind of images, which is developed by Natural Resources Canada, is it gives us an idea of what our fire danger is at a particular time of the year. So it tells us how easy it is to ignite it, how difficult the fire might be to put out, to control, and how much damage that it could do if a fire was ignited. And so you can see today, for most of Canada, it's a very low risk, so no risk. Then we've got a little bit of risk here in BC and a little bit in Alberta, and then some hotspots in red at the bottom. I know Kerri and Richard will be talking a little later on about the 2023 season, so I brought that up here as well. So you can see on this date in August, the 7th of August, 2023, you can see the pattern change significantly. So obviously in Alberta, we have a fire season that generally runs from May through to September. The challenge is the length of the fire season is increasing, which means that our potential exposure to wildfire smoke is also increasing, if that makes sense. So you can see here, A big challenge in southern Alberta, obviously up by the boreal forest, we've got a higher risk of wildfire damage as well in terms of the number of fires. And if we look at that over time, every year, on average, we burn over 2.1 billion hectares of land in Alberta and Canada. And so these little red dots here from 1980 to 2023, these are the dots and locations where we had fires that were greater than 200 hectares. So big fires, if that makes sense. And so while you can see we have high risk in the southern portion of Alberta and Saskatchewan, we don't have as many fires. Can anyone have any idea why we wouldn't have as many fires here? No forests? Yeah, we have a lot more. Yeah, no forests? That's right. Yep. So we have more grasslands here. Anything else? Agricultural land. Yeah. So the land has got value for us. Also, you'll notice where our cities are. So you'll notice where our cities like Edmonton and Calgary are. So we're not going to let a fire get out of control in an area that's densely populated. However, in the boonies or in the countryside, as I would say in Ireland, we are going to weigh out the risk of whether a fire should be suppressed or not, in terms of the financial cost and the risk to human populations. And so we might let a fire progress for longer than we would and get bigger than we would in those that are closer and densely more populated to an urban environment. What we need to think about, though, is not only the risk of the fire for property damage and the cost of suppression, though. More often now, we're thinking about the health implications of a fire that may be further away from us in terms of an urban community, but could now be transporting smoke to an urban environment. So we're starting to look at the health effects associated with smoke as well as the health associated with the fire, if that makes sense. You can see over time, we'll talk a lot about climate change, I think, in this discussion too, but you can see this is an image that looks at, on the bottom here, the fires from 1970 all the way to 2022. The blue and grey lines are the total areas that are burned, so the areas in millions of hectares. The grey shading here represents those areas that are burned from fires that are greater than 200 hectares. So this line at the very bottom here, my husband told me it's very hard to see the coloring here, but basically this is the number of fires that are present on this scale here, that are smaller than 200 hectares, greater than 200 hectares. So we've got less fires causing more damage. So most of the areas that are burned are associated with fires that are greater than 200 hectares. And that's something that's really important to consider over time because the frequency of fires goes up and down, but what's happening is the impact of the scale or the size of the fires are actually increasing. So the heat intensity and how much area is burnt has been increased over time. And again, this is the 2023 year, which is really off the scale. Another thing to notice here is the number of fires. Generally, there's between 2,000 and 6,000 fires annually across Canada a year. And when you start to think about the financial implications of those ones, it really becomes a little bit alarming for putting those ones out. So this is the cost of fighting fires in Alberta. So here you can see the cost in millions and in relevance to 2017. So you can imagine what the number would be now. But to put it into context, this is related to 2017. You can see here in terms of the fixed cost of something. So the cost of suppression in terms of like labor, and training and all those things has remained relatively constant. But the big challenge in terms of the cost is the blue line, which is the variable, and the cost of firefighting has gone up. So it's not like we're hiring more people or, building bigger programs. What we're doing is having to have these variable costs associated with fighting bigger and larger fires. That makes sense. Another interesting thing to look at here is the piece. So the green is the total. So you can see here in this context, this was a study that was done from 2017 backwards. And in that time period, you can see that 1, 2, 3, 4, 5, and 6 fires cost more than $1 billion a year. So we had more than $1 billion years in the 6 out of the 10 years that this was occurring. And this trend is continuing. So it's costing us a lot of money to manage these fires. Another way to think about it as well, I guess, is the cost. So we have fires that are in, rural settings, but we also have the fire in Fort McMurray, which we're probably all familiar with. And this kind of puts it into another different context. So when a fire moves from a rural environment into an urban environment and it crosses that threshold, the cost of the fire increases dramatically. So you'll see here, in terms of like claims for cars, there was 12,000 claims with an average of $15,000 per claim. 600 condos got burnt to the ground, 1,800 homes, and so it becomes a problem. And the reason why I'm saying this is not because it's expensive. It is expensive, and I think we can all grasp that. But now we're starting to burn things that are not wood. And with that comes a change in the characteristic of the smoke that we're generating from that one. So I kind of want you to think about that. We have smoke and fires that are associated with, a boreal forest or a grassland. But we're also, when we're thinking about wildfire smoke, thinking about the consequence of when that fire moves from the grassland or the forest into an urban environment and how that changes the pattern and the experience that we're having. And I don't want to leave anything out here, but we actually have more arson related more fires related to arson in a year, which is another, I'm throwing numbers out here left, right and center. I don't know if you'll remember any of these ones, but if you look at the numbers down here, we have in most provinces 50 fires for 100,000 population. If every fire is worth about $50,000, you could think that for every 100,000 people, we're spending $2.5 million on the cost of fires. And so I think one of the biggest drivers for me in my research and arson investigations was making sure that we could figure out how they were starting and who was starting them. And that applies also to wildfires, which is important as well to determine, are they natural, associated with changing climate, or are they associated with societal problems where more of them are started by arson-related issues. This is an example of the number of fires. So if we just quickly look here, there's about 33,000 fires in 2017, staying pretty standard. So, in the region of 40,000. And a lot of these ones are broken down into residential fires. And then we have vehicle fires and other structure types. So still a huge number of fires across our cities in Canada. Okay, so enough. It's expensive. We have them every year. Generally they run from May, September, as I was indicating already. So what do we need to know about those and how they're impacting the quality of health in urban communities? I'm sure we're all aware of how fires start. They have basically an abundance of oxygen in an area that has an organic carbon source. So it could be dead vegetation or dried leaves. We then have a spark, which is really important. And those give us the perfect conditions for a wildfire. So oxygen, carbon, and a spark, and then we have a fire. How do they start? Mostly in Alberta. 50% of them in Western Canada, including the Northwest Territories, are associated with lightning strikes. And so lightning strikes, while they count for 50% of the fires, they count for 80% of the total areas that are burned. And so these are natural phenomenons. Then an example here is the Maritimes. About 10% of them are associated with lightning strikes, just based by the geography and the topography of the Maritimes versus Alberta. So we're prone to lightning conditions. Another important thing to consider in terms of our wildfires are the stages of our wildfire. I'm sure many of you have a lot of experience, looking at the TV and you see fires that are basically starting, smoldering, moving into like building and growing, and then you hear in the news how quickly something is moving or whether it's being suppressed or not being suppressed. And so when we look at it, there are about 4 stages. And the very first stage is the non-flaming smoldering stage. And so that's when the fire begins. Generally it's very hard to think about, I guess, when we're thinking about these ones, like what is the smoke that's being generated or evolved in all of these conditions. So if you've got a smoldering fire, you've got a clear wispy fire smoke that you might see, not a lot of it, and you've got embers or the ground is slightly lighting. As you get to stage 2, you have a lot of oxygen, you have high temperatures, you've got things like convection and other elements that are helping to heat the environment up. And then with the presence of a huge amount of oxygen, the fire begins to take over, and you might have heard something like a flashpoint. And that's where everything that's present in the fire is at a high enough temperature for it all to combust at one time. And so you get a really efficient fire. And in those situations here, you can see the red line here represents the temperature. So you can see the temperature is building, we reach a point, and then the whole thing combusts. And that's something that's really relevant to us, because what is going to be in the smoke is controlled by what temperature it's burning at and how much oxygen that it has. So if you're burning something really efficiently, you'll have a different smoke characteristic than you would if you were smoldering. And then that progresses on. So your fire is fully developed. It's really, really hot. Everything is combusting together. You've got your fuel, you've got your oxygen, and it's really roaring. Eventually what will happen is the amount of fuel, so the trees or the shrubs or whatever it is, will start to be consumed. You'll still have oxygen that is present, but you won't have a fuel source for it. And so the fire will begin to go into stage 4, which is the decay, and you'll see it dropping down. The intensity of the temperature drops down, and you'll start to get embers and things like that are occurring. I'm sure many of you have watched a campfire and seen the same thing. The trick with the decay stage is that once you provide more carbon to it, so like more fuel, it can start again. And so that's the really tricky thing with fire suppression, and the evolution of smoke from those fires is that you can reignite those ones. And that's something that's really important when they're looking at managing those ones and when you're looking at the air quality in an urban environment following a fire like that. You can get a couple of types of fires as well. And so I'm sure you'll have heard of these. You can get surface fires, ground fires, and ground fires. And so surface fires, if you look at this cross-sectional image here, represents fires that are burning below the tree canopy. And that's important because below the tree canopy, you have things like dried pine needles and leaves and old pieces of dead wood, and they will burn differently than something at the crown of the tree, which generally is alive and greener material than something that's below and deceased and dry, if that makes sense. And so in these situations, you could have a whole ground of the floor of the forest could completely be degraded and burnt, and the crown of the tree could actually be okay. And that's actually very good for an ecological perspective because it allows the generation of more growth. It's like a cleaning condition, if that makes sense. The challenge comes when the fire in the subsurface and the surface moves to the crown of the tree, and the temperature increases dramatically, and you can have single trees, which is passive burning, or multiple trees, which is energetic burning, and the speed of the fire can increase dramatically, if that makes sense. Another one that you might have heard of before is something called a ground fire. And a ground fire, it's a bit tricky to see in this image, but if you look up here, you don't really see a trace of a fire here. But what it means is the fire is actually below the surface of the ground. And so it's in a smoldering stage. And that's something that's really interesting because it can last for a very long time. So I'm not sure if you've heard of these zombie fires before. This is a fire that could stay under the ground for months and months and months. And so this is an example of one that was found in Fort Lake, that was under the ground at the end of the fire season and reignited at the start of the next season, despite the fact that there was snow and cold conditions above it. It was basically being preserved under the ground and ready to go when the season and the thaw happened again. So it's a really challenging one for us to look at in terms of how to suppress such a fire, because you can't actually see it. There's no smoke coming from the ground, but it could ignite the fire the next season. So the fire from 2023 will start the fire in 2024. If that makes sense. An important thing to consider in terms of wildfires is how these spread. And so I'm sure most of you realize that like temperature plays an important role here. So obviously hot conditions, dry conditions, can cause material to dry out. So it creates the fuel. And then the wind comes along, provides the oxygen source. And then with the ignition point, the fire can start. And so the more material there is in terms of vegetation and the more wind there is, the more intense the fire is. Wind is also a really important piece in terms of direction changes. So wind patterns can change over a day, and that causes the fire to spread even more quickly in multiple directions, which is really challenging. So that's something that's really important. You'll notice in this middle image here, you'll see an area that is surrounded by a water body versus an area that's experiencing drought conditions. So generally speaking, if there's water in proximity to the location, it is more resilient to large-scale fires than something that is dry and in a drought condition. Makes sense that the carbon source is ready to ignite and doesn't have that buffer of moisture. And so that's something that's important too, as we are challenged with drier conditions during influences of climate change. We might experience more environments that are susceptible to fires in the absence of water. I guess I put this image up here to try transition over to smoke, because I know Kerri and Richard are going to be talking about smoke, and this is one of the important elements when we're talking about respiratory challenges. I don't know how many of you use a fire pit in the backyard or have been camping and have been tasked with lighting a fire pit. I can categorically tell you my fire pit never looks like this. Mine is always a bit more akin to something like this. Has anyone experienced that challenge before? And so the things that are relevant to a fire pit are also relevant to a wildfire or any fire in general. So where the smoke comes from is obviously from the material, and the conditions that it's burning in. So when you're trying to start a fire with material like this is the beginning stages of ignition. If you have, fresh wood, green wood, that kind of non-aged or dry or wet wood, you'll generate a different kind of smoke than you would if you had something that was dry. Make sense? So like you're always told to make sure you dry the wood before. It's because it will generate less smoke for you. Have you ever tried to light, for instance, like a pine tree versus a poplar? One will have a different kind of smoke than the other because one is more resin than the other. And so you'll start to burn heavier hydrocarbons when you're burning a pine. So it smells nice when it gets going, but the beginning pieces are going to be a little sooty for you. So that kind of translates the same way for when you're in a wildfire setting. So say, for instance, you have a woodland environment with really old trees, bark that's peeling, and very dry material below the tree canopy. You'll get a different kind of smoke than you will if you have a fire that's occurring in a younger tree stand that has got green waxy leaves, if that makes sense. And so that's important because the way the fire progresses and what is burning will dictate what's going to be in the urban environment 50, 100, 200 kilometers away, if that makes sense. So generally speaking, when you have the ignition point, you get like a white smoke like this. It's kind of slowly moving, but see-through. Then it dies away. Then you get a really roaring fire where there's complete combustion. And then you start to die out and you get a bit more soot and ash and that kind of material. So, the next morning when you're sitting with your jacket on that you wore at the fire pit the night before, you're wondering why it smells so bad. Well, it is related to how close you were sitting to the fire or what stage the fire was at, if that makes sense, when you were sitting there. So the same thing applies. So what are the toxic components of wildfire smoke? I don't want to say too much because I think Kerri and Richard are going to say a little bit more about this later, but I wanted to kind of give you some key words that I think you might hear now or later. Generally speaking, when you have wildfire, you have something, you have carbon dioxide, carbon monoxide. You might have something like NOx and SOx, nitrous oxides, sulfur dioxides. Thing called volatile organic compounds, which are very light. You might also have semi-volatiles. You'll have things like soot and particulate matter. What you'll find with most wildfires, carbon dioxide and carbon monoxide are the biggest component of the fire, of the gases. Then you'll get particulate matter, PM2.5 and smaller, which is that liquid or gaseous aerosol that's present and that's going to be brought into your respiratory system and cause you no end of challenges. But you'll also have things like metals and other elements depending on what the nature of the environment is that's burning, if that makes sense. So you'll have something that's a primary aerosol, so black carbon and then those primary organic acids, and they're directly derived from the smoke as it's burning in the environment. So like directly derived from the wood, for instance, that's burning. Those move up into the atmosphere and they interact with the sun and some other elements, and they are broken down or changed into secondary organic aerosols. And so when you have something that's released from the fire directly, it then moves in the environment and is converted and changed as it moves, as it goes to the urban environment. So it's not exactly the same. What can happen is material can move from the gaseous phase, so it could be a gas, and then it can sit on the particulate matter, or it could be sitting on the particulate matter and come off. So what we're really interested in looking at what happens to the smoke as it goes from the primary zone to the secondary zone, if that makes sense. You also have to think about things like when it crosses the urban barrier, you can see things like plastic burning, electronics, construction material and those kind of things will all release a variety of other chemicals, including things like halogenated carbons that might be in your furniture or in your electronics. It also has implications for wildlife as well because it can deposit into the rivers and those components. This image, I'm not going to go into too much detail in this image because I'm sure I'm running over time already, but these are the factors that affect smoke composition. And the reason I brought this image up is because you can see along the axis here, it goes from minutes to hours, hours to days, and days to weeks. So depending on how far away you live from the fire, the characteristic of the smoke is going to change. So you can see here, you've got black dots, brown dots, the combination of black, brown dots. And as you move along, they're changing. They're combining, getting bigger, getting smaller, dropping out, changing completely. And that's the bit that we're really interested in learning, is how do we understand what happens to the smoke as it moves from the source to the receptors to the urban environment. And so this study was done in the US. NOAA and NASA came together and they did a large study using aircrafts to sample a smoke plume across a wildfire. And so they took a plane and they threw it, across the fire, 20 kilometers up, across the fire, 20 kilometers up, across. So you can see and imagine the kind of amount of sampling effort that was done to complete something like this. And so that's something that's really important in terms of the scale of which we're investigating things. Things are really important at a local level, but also a national level, and there's research funding going into it. I guess, why do we care about it here? How many of you remember the fire from 2021? Yeah. Last year, the year before, right? It's not pleasant, is it? And here's another example of Seattle in 2020. And then this is the most recent fires that we saw in LA in the fall in the fall. So what you can see here are some really important things to consider. So would you say this one's kind of like a yellowy orangey color? And this one's kind of like a browny color? And this one's a black color? Which one would you prefer to be in? None of them, I'm guessing. None of them, I'm guessing. But the color of the smoke tells us a little bit about the chemistry of it. So sulfur dioxide, can generally be a yellowy color. This could also be sunset in a different color, but we'll be subject for this one. Brown generally is NOx, so nitrous oxides. And then this black color is from the burning of the buildings. So the material that are in the buildings, really heavy materials that are burning, causing this black soot. And so what we want to understand, as scientists, is when should I be telling you to stay inside and when should I be telling you it's okay to go out? I mean, that's something that's important, but how long is this going to last? Is this an acute condition where, you know what, don't go out for 2 days, it's going to end, the wind is going to come through, clean it all out and you'll be fine? Or are there long-term consequences to the material that's depositing out of this into our homes? How do we manage this? And so the way we need to look at it is, what is the material that's in here and how long does it last in the environment? That makes sense. And so that's the work that we're really interested in doing. There are some knowledge gaps associated with this. And so I'm sure all of you are aware, we do have air quality health index in Calgary and Alberta and Canada and lots of places around the world. And generally we do that with air monitoring programs. So you'll see things like stations like this that are fixed stations that are present across the country. And in Calgary, it could be north, south, east, west. And they're designed to sit there to measure something important. So you might have one that's sitting next to a highway that's measuring the NOx from our traffic emissions. You might have one that's on the eastern coast that's looking at material coming from a transatlantic movements or, Pacific movements. So they're put there for a particular reason. They're expensive and they're hard to move. And so as we're changing the influences, so now wildfire smoke becomes more prevalent to us, we don't have the infrastructure in place right now to be able to just pick it up and move it. If that makes sense, it's expensive. We do have other tools like this. This is the Calgary Regional Airshed group. So they have a mobile station that they can drive around. They can go anywhere to Canmore, those kind of things. And the thing that's really cool about this is they can respond to something. But there aren't lots of these about, if that makes sense. They're expensive. And so this is the challenge. What we have is a geospatial gap in the data that we have. So how do we model the risk associated with that one? So more recently, they started using things like low-cost sensors. And so you might have heard of these ones before. They're Purple Air. You can purchase them. They're about $300. You can put them inside your house, outside your house. And it's called citizen science. Basically, people are self-reporting the information to build a map of Calgary. And they have them all over North America as well. The challenge with that is not everyone has $400 to spend on a sensor like this one. And so we have large gaps as well in the spatial distribution of those ones. Some are situated high up, some of them are lower, some of them are in your kitchen. And so a little bit more work has to be done in terms of like developing the low cost sensor component. The next one, I'm sorry, I'm short of time, is we've done some work looking at the combination of things. So this is like, NASA and NOAA again, looking at finding things like remote sensing and satellite imaging, flying planes at different heights and using more mobile vehicles. You can imagine the cost of something like this, astronomical, to get two agencies to come together with tens of scientists that are working together. But they did get a really good indication of what is happening to the aerosols in particular fires. The challenge is it changes depending on what kind of fire you're at. So like what woodland was burning or grassland was burning. So more work needs to be done to be able to manage that one. We have recently just gotten a grant from NSERC to look at using unmanned aerial vehicles in combination with low-cost sensors. to be able to help us get better spatial resolution. So that is basically across Alberta, both at a particular set height, but also looking at it as you go through the smoke. So that's something that's really important. This summer we'll be doing some test flights, and so hopefully I'll be brought back maybe potentially to do a little quick summary of what it is. So that's pretty impressive. The other thing that we're looking at is characterization. So when we sample these particulates and the components of the gas and the smoke, what we want to look at is understanding what are the individual compounds that are present on our PM2.5. So I can explain and provide information to those that are doing modeling and health risk assessments that actually 10 of the most common chemicals are these. How would they impact human health, if that makes sense? And so we can get a little bit more information peeling back that onion. Here is your particulate matter, and here's what's bound to it chemically and what can have an implication on the health of our population. So that's where we're at the minute in terms of those ones. So if I wanted to summarize, wildfires are a natural part of Alberta's environment, but climate change can be making them more frequent and more intense and larger. The composition of the smoke that we're experiencing is associated with several factors, such as the type of the wood, vegetation that's burning, moisture content, that kind of thing. But we are looking at exploring the composition of smoke to give a better understanding of the implications of climate change and on human health. And we're using new tools and techniques, using low-cost sensors and unmanned aerial vehicles to give us a better idea of the spatial composition of wildfire smoke. So that's what I've got for you today. Hopefully it was a brief enough introduction to the concept of wildfire smoke.
Thank you, Dr. O'Sullivan. I would now like to introduce Dr. Kerri Johannson, who is an associate professor in the Departments of Medicine and Community Health Sciences and member of the Snyder Institute for Chronic Diseases at the University of Calgary. She is a research director for the Interstitial Lung Disease Program and director of the ILD Postgraduate Training Program at the University of Calgary. Dr. Johannson is an associate editor for Annals of the American Thoracic Society and the editorial boards of the European Respiratory Journal and the American Journal of Respiratory, Critical Care and Sleep Medicine. Dr. Johansson's research program is focused on understanding the relationships between inhalational exposures and ILDs, and how the environment and social determinants of health impact patient-related outcomes. Welcome, Dr. Johannson.
Thank you very much. And thank you, Gwen, so much for being here. Richard and I are both clinicians. We're both pulmonary physicians, and we'll be speaking a lot today about lung health. But we realize we really don't know much about wildfires. And so to put this all into context, we're so thankful for you to join us here today. So thank you very much. So I'm going to put this into a little bit of a clinical context, and the first half of this session today is going to be a little bit longer, and then we'll have the break, and it'll be a little bit of a shorter session after, if that's okay with everybody, because it all sort of ties together. So I'm going to talk a lot about air pollution in general, because that's what we know most about and what's been researched. We'll go a little bit through the wildfire smoke, and then what we do know about the health impacts of wildfires, now that we know what's in them. So I just wanted to introduce this concept of the exposome. We've learned a lot about the genome over the last 20, 30 years in medicine, and this has kind of been a new concept to think about the exposome. And the exposome is a framework to conceptualize all of your environmental exposures from conception to death. So there's specific external ones, things we can, to some degree, control, sort of what we eat, our activity, smoking. There's the general external environment, things that we're surrounded by, so green space, the climate, wildfires, and then what happens internally within each of us that processes those and then potentially leads to health or disease. And environmental determinants of health are really important. So the environmental and occupational exposures are thought to account for around up to 33% of the global burden of disease when looked at globally, based on all like respiratory diseases, cardiovascular disease, cancer, and are responsible for almost 20% of global deaths and a lot of disability-adjusted life years lost. And then there's social determinants, which are non-medical factors that influence health outcomes, and those account for 30 to 55% of all health outcomes. And I don't think that they get as much attention as they warrant in medicine in general and in clinical practice when we think about health. So I just wanted to bring that up here because our environment is really important, and we'll be focusing a lot on what we breathe in. So I'm just going to start with what are air pollutants. And these are called criteria air pollutants, and they have historically been regulated and defined by the U.S. Environmental Protection Agency. The big ones are ozone, carbon monoxide, SO2, NO2, particulate matter 10 and particulate matter 2.5. And this is their size. So it's PM10 is less than 10 microns in aerodynamic diameter. 2.5 is even smaller. And then there's ultrafine, which even gets smaller and smaller. And then lead, which we don't seem to talk about nearly as much. But the smaller the particles, and the particles are a lot of what we know from the health impacts from particulate matter, the size of them determines where they get deposited and then the impacts on our bodies. So the big ones, if you've been breathing in a campfire, you might, be blowing your nose the next day and so a bunch of black stuff comes out. That stuff was blocked and stopped in your upper respiratory tract because they were big particles, and they can be sort of cleared before they get down into the lower parts of your respiratory tract. But the smaller they are, the deeper they get. And within the lungs, they get to the trachea, the airways, and then the interstitium or the alveoli where gas exchange and healing and repair takes place. So PM 2.5, we sort of touched on this. They're particles and they can be comprised of all sorts of different things. So if you think of the size of a sort of a human hair, this puts it into context. They're really quite small, but they can be made up of all sorts of things. And some are very naturally occurring, like salt, if you're, by the ocean. And other ones are products of industry, fossil fuel combustion, and things like wildfires. So what the size of them and what makes them up can really determine the health impacts. So in general, PM 2.5 is a massive global health problem. As PM 2.5 exposure increases, the hazard ratio for all cause of death increases. It also increases for specific causes of death, so lower respiratory tract infections, stroke, chronic obstructive pulmonary disease that we tend to think of as a smoking-related disease, but we see it in a lot of non-smokers from high-exposure areas, places where they've got poor internal ventilation in low- and middle-income countries, lung cancer, and ischemic heart disease. And the vast majority of the population live in areas where the WHO air quality recommendations are exceeded. So the global scale of this problem is huge. So this is deaths attributable to ambient air pollution in 2012 by country. The darker the color, the greater attributable death to air pollution. And again, these are really vulnerable populations. So China and India, Russia, I think there's a lot of places we have no data for. We've enjoyed very good air quality in Canada historically. So it's not really been a problem. So we're not used to this. And I don't really like it, and I don't think it should stay. I think we got to go back to having really good air quality. So the London fog of 1952, I think, was really one of the first big public health crises of air pollution. So it was like the perfect storm over a 5-day period from coal burning in homes, coal-fired power stations, diesel exhaust from buses, and then this like anti-cyclone temperature inversion kind of perfect storm thing happened and just shut down on the city of London. At the time, there were 3,000 deaths. 100,000 people fell ill. The data have subsequently been reanalyzed when looking at expected deaths as to what they saw shortly after that. And actually, there's probably about 12,000 deaths resultant. And these are probably attributable to latent effects and chronic disease. Things like this led to the Clean Air Act. So the U.S. Clean Air Act in 1963, the Canada Clean Air Act of 1971, recognizing that our air quality matters for health. This was really the first big study, the Harvard 6 Cities study. This was from 1993. It's so funny, that's not that long ago, and the font looks so old. Like this, but yes, 1993, that showed that the highest polluted city in the U.S. compared to the lowest polluted city, there was a 26% higher risk of all-cause death and 37% increased risk of cardiopulmonary related death. So the people are dying of heart and lung related diseases attributable to air pollution. The epidemiology of this has just grown immensely and has been looked at in all-cause mortality, all sorts of different diseases. I wanted to focus on a couple of specific ones, largely lung diseases. But air pollution and chronic obstructive pulmonary disease, again, something we think is usually cigarette smoking related. It's thought that 8% of global COPD deaths are actually attributable to air pollution. This isn't an isolated smoking related disease. Air pollution increases the risk of developing COPD, your lung function getting worse over time, so your breathing's getting harder, impaired childhood lung development, and heart related mortality, sort of targeting these vulnerable patients with COPD. Traffic-related air pollution has been associated with childhood asthma development. There are loads of studies, and I think Rich is going to get a little bit more into asthma, but increased risk of getting asthma, having exacerbations from asthma, having hospitalizations and worse lung function. So traffic-related air pollution. Again, outdoor particulate matter and lung cancer. So this is a systematic review and meta-analysis, and it's really looked at a lot of all of the other studies. And when they've pulled them together, it doesn't sound like a big risk, but there's consistently an 8 to 9% increased risk of lung cancer attributable to air pollution. So not cigarette smoking, things like radon exposure and air pollution are risk factors for lung cancer. And so these are the chronic effects. PM2.5, again, increases the risk of heart disease and stroke. The higher the pollution levels, the higher the risk of all-cause cardiovascular disease, ischemic heart disease, so heart attacks, stroke, and other. This is very well characterized. So air pollution and acute health impacts. Air pollution causes symptoms and kind of irritation, which we'll get to with the wildfire component, heart attacks, asthma and asthma complications, COPD and COPD complications. My area of specialty, which is pulmonary fibrosis, we've found that it increases risks of acute exacerbations and death. And then one of our gastroenterology colleagues here, Dr. Gil Kaplan, several years ago showed that it was associated with even appendicitis. You'd think that wouldn't make any sense, but it's through mechanisms of systemic inflammation is sort of how it's thought to be. The chronic health effects, or as I've shown, increased all-cause mortality, so shortening people's lifespans, risk of lung cancer, cardiovascular disease and death, chronic, getting COPD, getting asthma, getting pulmonary fibrosis, and even things like dementia. So this has been shown that proximity to living to a high-traffic road is associated with an increased risk of dementia. There's a subsequent study on wildfires that I think the bottom line is like, the data are really robust. This isn't good for anybody. And the cleaner our air is, because it seems like it's a risk that should be able to be mitigated, the better we're all going to be off. So what about wildfire air pollution? These are pictures from my bike commute to South Health campus, May 2023. And then 2 weeks later when I really should not have been on my bike, but I thought it was going to get better and it just got worse and worse. I didn't think I was going to make it home, to be honest, in that air quality. So just looking at this, it was full of particulate matter. Now that I know it's kind of grayish, it's probably like NOx as opposed to SOx. But I still didn't want to breathe it in. So with all these like large, fine, ultra fine particulates and all of its components, I don't know what I was breathing in. And I had to go up a big hill to get home. So I had to do deep breathing. So I was just exposing myself even more. But using things like the Air Quality Health Index should have helped me prepare and risk stratify for this before the day started and I went on my bike. So this was, won't belabor the point, but I refuse to accept. I know we have wildfire seasons like on a geographic level. From a health perspective, I think we need to, I refuse to accept that we're going to have wildfire season moving forward, and this is going to be part of our normal expectation. 2023 was just an absolute awful summer, and I think as Canadians, we put up with a lot of winter for a beautiful summer, and I just don't think we should have to put up with this. So worst air quality on record, mass evacuations, over 10,000 firefighters deployed, and then of course people coming internationally to try to help. So the symptoms of wildfire smoke exposure, maybe you've experienced these over the last decade here in Calgary. So mild and common can be things like headaches, a little bit of cough, we might be making more phlegm, itchy nose, runny, watery eyes, and then kind of like irritation. But less common but more severe symptoms can be dizziness, chest pain, severe cough, shortness of breath, asthma attacks, heart palpitations or irregular heart rates. The health and health system effects of smoke and fire are broad, and we think about them. I think this is a really nice figure that sums up the health effects. They can be acute, subacute. They can be really complicated. They can lead to medium term and then emerging long term, which is where I think we need a lot more evidence and research to understand how this is impacting our population. So again, wildfire smoke is a significant contributor to air pollution, particularly PM2.5. And actually, if you look at the causes of when the PM2.5 levels exceed what we say is safe across Alberta, wildfires are the number one contributor. Because otherwise, we've always had really good air. It's like been beautiful generally. So the PM2.5 related to wildfires. So these estimates are again from modeling, but annual premature mortality ranging from 54 to 240 premature mortalities attributable to short-term exposure, and then the higher estimates of mortality attributed to long-term exposure, and again the economic valuation. of just fighting the fires, the health costs, the work absences, are massive. So the pathophysiology of wildfire smoke exposure. So again, we've got the smoldering and flaming fires, the wildfire smoke pollutants of all the different particulate matters, environmental gases, volatile organic compounds. They affect the autonomic nervous system, they affect the respiratory system and the cardiovascular system. And then they act at cellular, molecular, and tissue mechanisms. So again, if we think, your autonomic tone controls all of your blood vessels constricting in your body when you stand up so that you don't just pass out every time you stand up, that can be impaired. They cross over into the respiratory epithelium, cause inflammation that can predispose to infections, complications of existing disease like asthma and COPD, and then contribute to the development of subsequent disease. And then they get in and cause system-wide inflammation. So this was a Northern California study where they took blood samples on bad air days versus good and found that there were significantly increased blood markers of inflammation and inflammatory cell activation in the same people on good air days versus bad air days. So we think of, in general, inflammation has a role sometimes in fighting infections and, wound healing. But aberrant inflammation and long-term chronic without a purpose tends to lead to disease. So even without major symptoms, these people were having active inflammation. Mortality risk attributable to wildfire PM 2.5 pollution. So this was a global study at 749 locations, and found that the higher the PM 2.5, the higher the all-cause mortality, and then the higher the specific cardiovascular mortality and the respiratory-related mortality just spikes. So when you look on the health impact of this stuff is difficult to study because you can't randomize it. Like you can't take 1,000 people and expose them to high levels of particulate matter and then take 1,000 people and not expose them and then pretend that all those people are the same. So it has to be looked at really from a population scale basis of, what do we expect? What mortality has occurred in the population in the 10 years leading up to this? And then what has happened when we've had these peaks of air pollution and PM 2.5 related to wildfires. So that's how this is done. So they're challenging to determine causality, but the data are pretty robust that this is associated with adverse outcomes. So it's been clearly associated with asthma related emergency department visits with a 13% increased risk on wildfire smoke days. I thought this was really interesting, that it's been looked at in mental health. So this was across California, and they looked at from the 2020 California wildfires and found a consistent relationship between PM 2.5 from wildfires and mental health related emergency department visits. So I think beyond sort of the physiologic, the cognitive impact of that feeling of suffocation, if you've ever just been outside when you can't see the sky for day after day and it feels kind of like a zombie apocalypse is happening. I think for people that are dealing with mental health issues and maybe are struggling, that I think this seems to be enough to push people over the edge. So it's really difficult. So again, we've talked about the costs, the estimates of the acute and chronic impacts. I think the bottom line is there really are, and I updated my search today, there are no long-term health and safety data on chronic recurrent high levels of exposure to wildfire smoke. These are the things that I found most recently. So, from a neurologic perspective, found an increased risk of incident dementia after 3 years of chronic exposure to wildfire smoke. So it was both PM 2.5 and then wildfire specific. The long-term health effects of wildfire exposure, this scoping review really only found 17 papers to sort of look at that it may be associated with all sorts of adverse outcomes. And then this was one that was exposure to wildfires and cancer incidents across Canada using population-based data. And the conclusion was that it may be associated with increased cancer risk, but we really don't have robust enough data. And so I think if we extrapolate what we know about air pollution is not good for anybody. Air pollution has clearly been associated with the risk of almost every type of major disease and increased risk of all-cause mortality, as well as symptoms and impaired quality of life. If we extrapolate that to what sounds worse and is a chronic, recurrent, high-level exposure with wildfire smoke and even more complicated components, I suspect we will find that there's a lot of adverse outcomes, but I think after the break, we'll talk a little bit more about what's being done here with with some of our teams through the Snyder Institute, to better characterize that, in our populations. And Thank you very much. I think we'll take our coffee break and then come back for the second half.
Welcome back, everyone. I hope you all had a chance to grab a drink and a snack. I would now like to introduce our next speaker, Dr. Leigh, who is a physician scientist and a senior associate dean, faculty affairs in the Cummings School of Medicine at the University of Calgary. Dr. Leigh's areas of interest include understanding the basic mechanisms underlying airway remodeling in asthma, the assessment of airway inflammation, and early phase clinical trials in asthma and COPD. His clinical practice focuses on severe asthma and other airway diseases, and he previously served as the chair of the Department of Medicine before taking up his current appointment in January 2020. Dr. Leigh was elected as a fellow of the Canadian Academy of Health Sciences in 2021. Welcome, Dr. Leigh.
Thanks, Mary. So, hope everyone's enjoyed the coffee and the carrot cake. It looked good. Good. So the question that you heard both Kerri and Gwen pose was, what are we doing about challenges that we face? And what are we doing here at the University of Calgary specifically to better understand the health effects of wildfire smoke on human health? So we've alluded to this already, but these are some of the media headlines that we all would have seen in the last couple of years. So Fort McMurray, 2016. The town of Lytton, BC, destroyed 2021. Jasper, destroyed 2024. And of course, we just saw earlier this year the devastation that occurred in, not working, no, but turn on, occurred in Los Angeles. And so when Gwen alluded to these zombie fires that burn underground throughout the winter and then come back the following year. And again, you've seen images like this tonight, but this is September 2023 in Canada. The red dots are uncontrolled wildfires. The blue dots are deemed to be controlled at the time. And the yellow dots are being held fires. But an awful lot of red dots that you see there, and really concentrated in Western Canada, but in fact burning throughout the country at that point in time. I wrote a piece along with one of our fellows at the time in an international journal, just highlighting the impact of global warming and wildfire smoke pollution emerging as a major threat to respiratory health. And Dr. Johannson has already outlined some of those aspects of it, but really recognizing that this is a major global problem and it's going to impact certainly respiratory health, but again, as Kerri alluded to, other areas of health, cardiovascular, mental health, stroke and things like this. And so what do we know to be true at this point in time? We know that the summer of 2023 was Canada's most destructive wildfire season ever recorded. The other speakers have alluded to that. We know that in the summer of 2023, 18.4 hectares of land was destroyed, and that's 6 times more than the 10-year average that Gwen pointed out, which she had 2.1, I've got 2.5, but it's in that range, a million hectares in the previous decade. We also know that in recent years, the average temperature in Canada has increased roughly at twice the global rate. I don't know quite why that is, but that's been the fact. And in 2023, Canada experienced the warmest summer in over 80 years. We know that with a warming climate, wildfire smoke emissions will worsen, with widespread implications for human health and, of course, public policy. We also know that wildfire smoke is now and will increasingly be a leading contributor to health-damaging air pollution that Kerri's alluded to in Canada. So that's what we know to be true. Kerri showed this picture, so I won't dwell on it, other than this issue that smoke particles or the fine particulate matter that comes from wildfire smoke is related to this particulate matter 2.5 or 2.5 microns, and that's the thing, the size, it's about 1/10 of the size of a human hair diameter. So these are really, really fine particles, and they're getting deep into your lung spaces and causing damage. And again, Kerri showed this picture where the majority of 2.5, PM2.5 particles in Canada in 2021 at least were generated by wildfire smoke. Again, the impact of wildfire smoke on medical events. So you see, we've got all-cause cardiovascular events. You've got myocardial infarction. You see when the wildfire smoke density in the red is increased, a dramatic increase in heart attack or myocardial infarction, ischemic heart disease. You see heart arrhythmias. This is irregularities of the heart, if you would, atrial fibrillation and these types of things. Heart failure is increased. Blood clots on the heart are increased. All-cause cerebrovascular events, these are strokes and the like. And of course, all-cause respiratory events are increased too. And Kerri alluded to the fact that chronic obstructive pulmonary disease is also increased. And so you're just highlighting again all-cause cardiovascular events and all-cause respiratory events. And of course, cardiovascular and respiratory events, even without wildfires, are the biggest causes of mortality in human health that we have. So this just increases that risk. And these are some data from Alberta Health Services showing that, again, looking at the years 2018 to 2022 and then looking at the period 2023 when we had those really bad wildfires, this is the number of asthma physician claims, and that's our best surrogate to mark how bad was asthma that summer. So you look at, again, when physicians put their claims into Alberta Health Insurance, they put a code for asthma, and you can see that those codes went up by 16% in 2023. You look at the number of asthma medications dispensed during that time, again, increases by 12%. If you look at the inpatient visits and emergency room visits during that time, it increased again by 17%. So we recognize that asthma, it goes up during the periods of wildfire. And of course, it makes biological sense that it would. Asthma is caused by irritation to the airways, by pollution like wildfire smoke, and also by allergens. These are things like your house cats and things like that. But certainly asthma is one of those things that clearly gets impacted. Again, this is some data from Fort McMurray. And what it shows is that the firefighters in Fort McMurray had a 2.5 odds ratio, twice the odds, 2.5 times the odds of developing asthma after being exposed to wildfires in Fort McMurray. So if you didn't have asthma before, being exposed, and these are people being exposed to the front lines, being exposed to wildfire, in this case during the Fort McMurray wildfires, increased their odds of developing asthma afterwards by 2.5-fold. Again, this is a picture of New York City at the time, and again, the impact is, of course, the wildfire smoke blows for many hundreds of kilometers away. And so some of the pictures that Gwen showed of Calgary back in 2021 weren't necessarily wildfires in Alberta. There were wildfires burning in Northern California, with that smoke blowing several hundred kilometers towards us. Wildfires in BC. And this picture in New York, and you can vaguely make out the new World Trade Center tower there, but just vaguely, was taken, and these are wildfire smoke coming down from Quebec, okay, and again, probably blowing across from Western Canada too. And this resulted in increased emergency department visits in New York City and other major centers in the US at that time. So again, you can see June 2023, as the wildfire smoke increased, you see the number of asthma emergency department visits increasing proportionately to that. So the brown bar is meant to represent the smoke wave there, and then you can see the asthma visits to the emergency department correlatingly increasing during that time. And then as the smoke dissipates, the asthma visits drop off as well. Again, these are some data at the same time, again taken from New York, published in one of the medical journals, and just again showing, if you would, look before the smoke came, so May to June of 2023, then the smoke wave of early June 6th to 8th, and then after the smoke wave. And what you see is, for example, if you look at in New York City, it says all age groups to 523 visits, and then it increases to 783, and doesn't quite get back to normal even after the smoke is gone. So again, recognizing that the smoke is causing that. And crap happens across all age groups. And it happened, like you can see the different boroughs of New York at that time. So just emphasizing again, the odds ratio, increased risk, as it were, in this case about 1.5 times of having to go to the emergency room because of your asthma during that time. Kerri showed this picture. I won't dwell on it too much. Suffice it to say that while she and I are respiratory physicians, and therefore we deal on the lung to a large degree, We recognize, we've both shown you some data that increase cardiovascular risk. So we know that firefighters who are exposed to wildfire smoke have increased risks of cardiovascular disease. Been alluded to things like mental health, cognitive decline, stroke, cancers. And we don't really know all the answers to these things as yet. Probably the best evidence we have is around respiratory disease. We reckon that there's a lot of other stuff to find out at this point, which we haven't got there yet. So what don't we know yet? Gwen's told us that wildfire smoke contains a lot of substances in those smoke particles. I've listed some of them there again. I won't dwell on them. We actually don't know all of the constituents of wildfire smoke particles. We know a lot of them, but not all of them. We know that the wildfire smoke attracts a lot of our attention during the peak fire season, usually July to September. And as Kerri said, once the wind blows out the smoke and we get back to normal, we go, well, air quality is good again, and no one thinks about the wildfire smoke from, late October through to about now, and it'll start up again in the next month or two, I presume. And so we don't understand the longer-term impacts of what wildfire smoke is doing to our health, be it in terms of cancer risk, pregnancies, mental health, cognitive impairment, and these things. So that's to be determined still. And we know that given the global warming crisis and projected increase in wildfires, we have a number of research gaps. And again, Kerri alluded to those earlier, Gwen alluded to those. And we need to find those out. And as a university, our job as academics is to develop new knowledge, make new scientific discoveries. And that's what we're about. And so I was fortunate enough to be on a research team that last year was awarded through the Canadian Institutes of Health Research, which is a federally funded research agency, what's called a lung team grant, and was $1 million to study the effects of wildfire smoke on human health, and particularly lung health in particular. The grant is actually led by Paul Cubes, who unfortunately for us has just recently relocated to Queens, and colleagues at Queens, and I was part of it. And the person from Calgary who's really led this but couldn't be with us tonight is Dr. Christina Thornton, but she gets all the credit for some of the work that I'll show you here. And then Dr. Ranzau is an environmental biologist up at the University of Alberta, and he's a key player in this. And so, again, Kerri showed some of this, but what we're interested in finding out is what is the effect of wildfire smoke, short-term and long-term, on the nervous system, because we really believe that it does have an impact to play on the nervous system, particularly as the nervous system interacts with the lungs. We call the autonomic nervous system, the part of your nervous system that you don't control, breathing, heartbeat, and these things, and we think that it has an important role to play. Okay, the respiratory system, and then, as we've alluded to, what's happening in your cardiovascular system as we go along. And so the grant that we got for $1 million is looking at the effects. What we proposed in the grant, why we got the funding, is we said, we think that the airway inflammation from wildfire smoke exposure is driven by the combination or the synergistic impact of fine particulate matter. Those are the 2.5, the PM 2.5 molecules that we've heard about, and bioaerosols. You may not have seen it, but both Gwen's slides and Kerri's slides had the word bioaerosol on there. What do we mean by that? And we actually think, and the novelty of our grant is that in addition to all the bad things that Gwen and Kerri said, that wildfire smoke is able to transmit over hundreds of kilometers, is there actually microbial particles, bacteria and other particles, bits of fungi and things like that are being transmitted. And you go, well, how the heck can these things survive? And I'll come to that in a minute. And we think that the nervous system impacts your immune system, good evidence for that, and that if the wildfire smoke can somehow damage or impact your nervous system, that's going to impact your immune system and maybe lower your immunity to the ability to fight the effects of wildfire smoke in your body. And just the fact that, again, if you're being exposed to these bits of bacteria, not whole bacteria, bits of bacteria being floated over from BC or Northern California, that those bits of bacteria are going to be sensed by your immune system, and your immune system is going to mount an abnormal immune response to those bits of bacteria and maybe set up some form of, not only acute immune response, but who knows, maybe autoimmune dysregulation down the way beyond that. And we also think that in the asthma world, we divide asthma up into what's called eosinophilic or allergic asthma, which is relatively easy to treat. I'll say most family doctors can do that well. There's also a form of asthma which is non-allergic, and we think that's the form caused by the wildfire smoke, and that's not easy to treat. And so we have a clinical need or clinical gap in that area where the type of asthma caused, or the type of inflammation in the asthma caused by wildfire smoke and cigarette smoke, but in this case wildfire smoke, is not easily treatable by the currently available medicines that we have. So again, we're looking at that aspect in the grant. And so there's this new concept or new biology, if you would, called pyroaerobiology. It's really studying the biology, if you would, of what's happening in fires. And so we all know about, you can have pyrotechnics and pyromaniacs, and these are basically people who love fires and pyrotechnics and fireworks shows and this. This is pyroaerobiology, and it's really studying the effect of what fires are doing. And again, I'm not going to dwell on this because Gwen touched on this. Suffices to say maybe on this part here is that we recognize, clearly I'm not going to get, that the microbiology is a piece that hasn't really been mentioned. We're just talking about this, the fact that bits of bacteria, that's pathogens, can be transported on the fine particulate matter that is generated in wildfire smoke and transported from Northern California to, for example, Calgary, Alberta. So that's the novel piece here that we're really looking at this point in time. And so again, we recognize, majority of this work is looking at the ability to transport microbes. Microbe is just a fancy way of saying bacteria and fungi and maybe bits of virus. We don't really know that yet. And again, you can say, but what the heck? This fire is burning at 1,000 degrees. It'll incinerate everything. But again, Gwen alluded to this a little bit. Most life forms can't live beyond 290 degrees Celsius. But of course, not everything's incinerating at 1,000 degrees. There are bits of soil particle and other pieces that actually don't burn that hot because they're protected. Or the bacteria can live within the soil particles that are being picked up by the wood ash or whatever that's being transported across. And so these soil particles then contain just enough oxygen for those bacterial species to live in there, and they can again be transported, and we aerosolize those in Calgary, even though it originated in BC or Northern California. One more piece here. And so again, sort of the notion of our grant is that what if we can identify these bits of bacteria coming across, and what is their effect on the human health as we move forward? And so you say, well, that's a crazy idea. Where on earth do you come with that? Well, actually, here's some data. So you can see, this is what's called bacterial colony forming units on the y-axis. And you can see what happens in ambient air. And then you look at what's happening in flaming wildfire smoke, and you can look at the bacterial colony forming units. They clearly increased, okay? And then to Gwen's point about those smoldering fires, the ones that haven't quite gone out yet, you call them ground fires, I think you call them. You can see that the bacterial units are still increased. So there's biological plausibility as to why this works. And so part of our experiments, we're taking firewood in A, we're taking mulch in B, we're taking peat in C, okay? And we're burning all those things either alone or in combination in a very controlled way in the laboratory. And then seeing and then we're collecting that smoke and infusing that into media, and then looking what that does. And here's the media in terms of bacteria. And then we're measuring outside ambient air quality that you've heard about already. This is on Dr. Zhao's back deck in Edmonton in August last year, measuring just the stuff. And you can see the fluid in that little canister. It's not clear. It's sort of milky white. Okay, so this is not good. I mean, the stuff that you think you don't see it so bad when it's so big. When you start to concentrate it down, it's got these components that we've heard about, these noxes and soxes and who knows, bits of bacteria. And then we start plating it out, and you actually this fluid can actually grow bacteria, okay? So our hypothesis is not that far-fetched, and maybe this is when you're breathing in wildfire smoke, in addition to all those bad things you're breathing in that Kerri and Gwen spoke about, maybe breathing in bits of bacteria as well, and maybe your immune system is responding to those in a way that we don't know the answer to yet. But this is some of the work we're doing here. And again, I think Kerri showed this. So this is so that we didn't show this. So we've done some early work, because again, we're funded last year. So Dr. Cubes, who leads the grant, looking at a mouse model. So again, a lot of what we need to do to begin with, you're doing animal models, because before we take it on. And so what he's done here is he's looking at inflammatory cells. looking at inflammatory cells, and you can see this is wildfire fine matter. So these bits of soot and these PM 2.5 materials, and these are the inflammatory cells. Okay, so this is 20 microliters of wildfire fine particulate matter, and you can see there's not much inflammatory cells here, but there's a green. That's some. It gets more as you go up to 30, and by the time you get to 50, it's getting red. That means a lot of inflammatory cells here. And for now this little area up here, you can see it's starting to increase. And again, just in the middle, a bit of redness there. So clearly, the more exposed these mice are to these wildfire fine particles, the worse the inflammation in their lungs is getting and their bloodstream. And then Dr. Cubes looked at some fluid out of the lungs. We just wash the lungs out and we see what's in there. And you can see that if you have the neutrophils, which are the inflammatory cells in the lung, and you can see we give these mice over, which is a model to try and generate asthma. It's just it's egg albumin, if you would, and it's a good model to generate that. We give them over and fine particulate matter in the green. You can see that the number of inflammatory cells goes up. So if you're asthmatic and you're exposed to wildfire particulate matter, you're going to get worse inflammation in your lung. And he's just showing this in mice. And then the eosinophils, which is that allergic cell, same thing happens. And the purple was just we're trying to mitigate that response by blocking the effects or some sort of intervention. In this case, it's a medication we're trying to use. We're just trying to block the effects of that. We actually have to say we're not being terribly effective at this point. So more research to be done to try and find the right antidote to dampen the effects of wildfire smoke on inflammation in the lung. But we haven't got there yet. And then again, one of the things that the Cubes lab does really well is they do lifestyle imaging. So they can monitor inflammatory cells in the lung and see what they're doing. And so these green things are macrophages. These are the patrolling sentinel sentry cells in your lung. And we all have them. They're patrolling these are the little alveolar sacs, your breathing sacs. Everyone's got these little green macrophages. Consider them the sentries. They're patrolling your lungs as you sit here. Here's the bacteria coming in, and that little macrophage moves towards it, gobbles it up, and bacteria is gone. Okay. This is what happens when you breathe in cigarette smoke. The purple magenta color, all those inflammatory neutrophils, they overwhelm the system. They can't cope. And what he's showing you here is that not only are the overwhelming neutrophils coming in, but these sentry cells, these macrophages, are being paralyzed. The cigarettes, the wildfire smoke basically paralyzes these cells, and they can't move to where the bacteria are, and they can't ingest and gobble up those bacteria. So not only are those cells being overwhelmed by the other inflammatory cells, but they're being paralyzed in the process. And so, these are some of the things we're looking at in this grant. We're burning particulate matter. I showed you the peat and the mulch and the wood smoke, and we're trying to generate what would happen in real life. We're using primarily animal models initially to try and address that. What's the effect on the nervous system? What's the effect on the lungs? What's the effect on the cardiovascular system? We're also trying to look at this in using human studies. So we've collected sputum over many years, and we're trying to match the sputum inflammatory cell counts that we have in a biobank with the summers that we've had over the last 10 years. And again, our preliminary evidence is that we look at the summers going back to 2015 or so, we see a dramatic increase in inflammatory cells, in the bad type of inflammatory cells in the summers of 2023, for example, versus previous summers. And again, we're correlating that to being the effect of that, incredible season of 2023 when we had all these wildfires burning. But of course, at this point, it's a study of association. We can't prove that the inflammatory cells that we're seeing in 2023 are caused by the wildfire smoke. But at least it's a good hypothesis for us to work on. Again, we can now try and prove that in the animal models. And again, we might have opportunities in the future to take people during wildfire season and collect their sputum and collect their blood and analyze them at that time to see what it's looking like. And again, I'll just end off there. So again, we think, and I've shown you mostly the best evidence again is for asthma. We know that wildfire smoke increases asthma visits to emergency room. It increases the asthma exacerbations or the type of asthma attacks, and actually causes new onset asthma, in particularly firefighters, for example. And so we see that through increased inhaler prescriptions, increased emergency department visits, hospital admissions. We measure asthma symptom scores. We can see that worsening asthma, worsening lung function. And of course, us as taxpayers, it's an important thing as we see increased healthcare utilization. So as taxpayers, of course, healthcare costs go up. And Kerri, I think that's my last slide, so I'll hand it back to you to close us out.
Microphone. Now I kind of want a microphone. Move around while I'm doing this now. So this is really depressing. And so I'm going to focus a little bit on like, what can we do? Because there's things we can do. And hopefully we'll walk out a little bit empowered and prepared. So what can you do to reduce the health risk from wildfire smoke exposure for yourself? There's sort of a standard set of interventions that you can do personally to protect yourself. And I sort of say the same thing every summer. We've got the most effective ones are the hardest ones to do, and the least effective ones are probably the easiest interventions. So this is a framework sort of for overall health. The top box saying relocation, so just pick up and move. I think we'd all move to somewhere closer to the equator all winter if it was just an easy thing that we would do. Everything would be easy, but that's going to be very difficult and not feasible for everybody. Engineering controls are important. Administrative controls, stay indoors, avoid heavy or prolonged activity, wear a face mask. I'm just going to move on. My friend and colleague Chris Carlston from the University of British Columbia published this a few years ago about, this is particularly focused on respiratory health, going through populations at elevated risk. Are you one of those groups? Household exposures, other things that can make a difference, and then mitigation strategies. So I'll go through each of those in a little more detail. So know your risk status. So populations at elevated. So everybody's got a baseline risk, but when people tell you to use the air quality health index or to use your WeatherCan app and see, the air quality today is like 10 plus, or is it a 1 or a 2? The highest risk people should be, are recommended to, take more precautions. So these are older people. What is older? We're all older, but the older you are, the greater your risk. People who are working in these environments, and we were just talking about this, I think like firefighters are a particularly understudied group, that are being exposed, but it's a lot of people that work outdoors. So if people are working outdoors throughout the summer months and being exposed, they're at particularly high risk. So if you're a fetus in development, take special precautions. If you have underlying cardiopulmonary disease, and if you're pregnant. So just recognizing that those are particularly vulnerable groups that we think of, and to interpret the air quality index recommendations, for your group. So mitigation strategies in the household. So having HEPA filters, and air cleaners, are helpful. And I'll go through those in a little bit more. How you ventilate your home. If you're bringing dirty air in from outside and spreading it into your house, you're just bringing the pollution in. So it's recommended to turn valves off, close windows, don't leave the doors and windows wide open on that. Keep your indoor air clean. I think fuels and stoves that we cook with are sort of an emerging, interesting area. We think of, it's very well researched when people live in poorly ventilated huts, sort of in low and middle income countries, and are burning biomass for cooking. It's really bad for children and largely women that are doing the cooking, and it's been associated with all sorts of things. But we think of gas stoves, and they're actually a pretty emerging concern for PM 2.5 exposure in your home, which is why I don't cook. Because I think it's just a risk mitigation strategy. But just to be aware of all the things that we're doing. So your personal actions, eat right, drink lots of water, try to exercise, don't smoke. I think, Gwen's really convinced me to not get a backyard fire pit. I know everybody likes to have one, but we're just adding to it. Things like having prescriptions on hand. So if you have asthma or COPD, it's not a time in the middle of July and bad air quality time to run out of your inhalers. So it's just sort of being prepared and managing comorbidities. And then other mitigation strategies. These are the things that we tell people to do. Wear a face mask. If it's not an N95 fitted mask, it's probably not going to do much. When it's hot out, and people are walking around, no one really wants to wear one of those. So it's a tricky thing. If you really want to protect yourself, you have to have a fitted, appropriate mask to filter out all of the particles and the gases and the sort of noxious chemicals that are going to be coming in. So active transport. So again, trying not to contribute to the problem. The vast majority of pollution in Calgary is traffic related. So if you can reduce that, but not on really poor air quality days where you're breathing a lot, plan your exercise around, so the summer is problematic in Calgary because everybody's training for a triathlon. Everybody in my neighborhood is running 20 kilometers a day. And so wondering should I not do that today? Should I wait until next week? So sort of planning cause you want to reduce how much air is getting into the deep parts of your lungs because it's carrying all the junk with it, and then monitoring your local air forecast. So the Air Quality Health Index, this is really the tool. It's sort of a big picture tool. It doesn't tell you all the details. It's really a population level intervention, but it's to estimate your risks and recommend mitigation strategies. So if you're low risk and you have no underlying cardiopulmonary disease, that in stages 1, 2, and 3, everybody can just keep doing everything. You don't have to have any interventions. If you're if the Air Quality Health Index is getting to 4 to 6, and let's say you have underlying asthma, or you're pregnant, or an underlying heart condition, now is when you really should start mitigating your behaviors and thinking, how can I protect myself? 7, 8, and 9 is starting to get to the point where everybody should be taking these interventions. And when it's gotten to, the 7 and above, and particularly when it's been 10 plus, so kids' soccer practices are canceled. Kids are not. So first time in my life, 48 years in Canada, I don't ever remember people not going outside in the summer because of weather, but kids not going outside for recess. And that workers really shouldn't be working outside in construction or other sort of external activities. So we really need to develop some safety policies, I think, around occupation and activities when things are in this, when it's getting 7 and above for the general population. So this is just how it looks. Sort of in my neighborhood, gives you the weather, and then gives you low risk, and sort of, again, tells you, are you an at-risk population? Enjoy your usual outdoor activities. In the general population, ideal air quality, get out and go for a bike ride or a walk or whatever. And as it gets higher, it will give different recommendations. So an easy tool that you can use and implement. Indoor air purifiers. They are pricey, so I think this is a barrier for a lot of people to have these in their home. And so, it's recommended these high efficiency particulate air filters with a particular certification. They'll have them at sort of all your major stores. But they don't clean your whole house. The size of it filters out a particular volume of air, so it's usually by a room. If you have one in your kitchen, it's not going to be effective for your whole house or for the bedrooms. And I know a lot of people will sort of move it to where the kids are during the day, and then at night try to have one in the kids' rooms or something, with the most vulnerable people in the home. Recommended to run at the highest settings, replace the filter so that it's effective, and then again, keep the bad air outside and keep good clean air inside. So, basically know your air, use the Air Quality Health Index and your own personal susceptibility. Listen to your symptoms. If you think everything's fine, but you're coughing or your nose is running or you're just not well, go back, take that as a precaution. Reduce your strenuous activity outdoors. Go to the gym where there's filters in the air and it's all clean instead. Use a HEPA filter. If masking, wear one that's going to actually protect you from all of the components. Sheltering in place, just staying home where the clean air is. And then I always think this is a really good opportunity. I'm probably preaching to the choir here in this room, but to think about the other things that we're putting in our lungs. So smoking, vaping, campfires, leaving our cars idling, all these things that are making things a little bit worse. It's just a good opportunity to sort of re-examine our concern about our air quality and our personal exposures. And again, have your medications on hand. Always good to be prepared. So I think in conclusion, I hope this has been a useful session. We'll go into the Q&A right after this. But wildfires have become a chronic exposure. Air pollution exposure is harmful, and wildfire smoke seems to be even worse. Our entire population is being exposed, broad populations for chronic periods. There are ways that you can reduce your exposure and mitigate your own risk. And I think, I kind of feel useless when I say things like someone's got to do something. I don't know who that someone is, but this does not seem to be